Hello, welcome to the THENEWSTACK Makers, a podcast where we talk about at-scale application development, deployment, and management. Hey everyone, Alex Williams of the THENEWSTACK here. I am lucky to have Luke Marsden of Dotmesh joining us. Let me see if I can get, there we are. How are you?
Very well, thanks, Alex. Thanks for having me on.
Oh, you bet. Luke is from like the way back day. Luke goes like back to like circa 2013, 2014, when I think you're starting to look at how you think about state with containers and Kubernetes. And so your journey has been a long one. And you had your own company in the container storage space. I know you worked with the team over at Weaveworks, and now you have Dotmesh. So tell us a little bit about Dotmesh. What is it that is for you so compelling today about this world we're in now? Because we've talked so much about immutable infrastructure, and the question of state has been left in a state almost like over here, but we're starting to see it move more into like the main arena for discussion. So give us some idea what it is.
Absolutely, yeah. So the project's called Dotmesh, and we launched it a couple of weeks ago now, and it's really about the ability to capture the stateful parts of your application during development and testing, just like you capture your code using version control. So if you go to a DevOps team and you say, hey, do you version control your code? Then the answer is, yeah, duh, obviously. And we're saying that the same idea should be applied to data to make it possible to capture development states, even when you have microservices and you have more than one microservice at a time, and be able to capture those states together and share them to enhance developer collaboration, to improve CI, and in the future also to help bring snapshots of production state earlier into the test cycle, so that you can reduce the number of errors that you have in terms of issues hitting production code.
Okay, so there's a lot of, so I watched the video and that you have on the site. I kind of felt like, I was going to meet a, like a creature from Stranger Things for a minute. So you got me with the intro. Everyone, you got to watch it. It's pretty cool. It's like, dun, 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 you're like, oh. And
yeah, I might have had a lot of fun with the graphics.
Yeah, I think you did. I could tell. So maybe we could just do a quick recap of that video. Could maybe just start with the intro to show people how fun this is. So, and then it's a lot of your voiceover. Maybe you could just give us a glimpse of it. Just give us a taste of it, and then we can talk about it.
Yeah, absolutely. Sounds perfect. So let me just see if I can share my screen here. And then hopefully you should be able to see a presentation. Is that right?
Yes.
Cool. So yeah, I'll just sort of blast through the first few slides here to give you and the viewers a flavor for what we're doing here. So Dotmesh is all about bringing data into the circle of control. But before I talk about the circle of control, let me paint a picture. So we're all software developers. We know what a bad day at work looks like. And we spoke to dozens of software teams while we were developing the ideas that went into this product. And there are several common themes that came up, both in those conversations and also in our own professional experience working in software teams. Now, the first problem, and this is a big one, we're not going to solve this one in one fell swoop, but the first problem is that you deploy some code, it passes all the tests in CI, and then it blows up in production. it causes a production outage. You have to roll back the code, and that's stressful. It would be great if you could have that happen less. And I've seen that this affects software teams in companies all over the planet. It's a common pain point. And why do things blow up in production? Well, they blow up in production because production is different to all of your other environments. It's different because the data in production is different, and also because the inputs to production are different. So you have real users doing things that your test suite didn't expect. So that's the first problem. The second problem, now I borrowed this graphic from XKCD and modified it a bit. The graphic is a few years old, and it used to say that the #1 programmer excuse for legitimately slacking off was that my code was compiling. Now, it's 2018. Compilers are a lot faster now, but the thing that still slow people down and cause jousting in the office is that integration tests are slow, and in general, CI pipelines can be slow and flaky. And so when we spoke to many teams who experienced this problem of low velocity, of not being able to ship code fast enough, we often found that a slow and flaky CI pipeline was at the center of the problem. And of course, there's this interesting thing about tests, which is that the more realistic your tests are, the slower and flakier they tend to be, because they have to set up more state and they have to set up more pieces that interact with each other, especially in a microservices environment. And that leads back to the first problem, which is that the tests weren't realistic enough. And that means that you're more likely to have more production outages.
So this can be really a visibility issue, can it? I mean, you just don't know, right? You know, if you're doing tests and it doesn't work, and then it fails, and you have a failure in production, right? It's often you're just then now you got to go through every little thing, don't you, to see what happened. You don't really have a snapshot.
Exactly, and there's this interesting idea with testing, which is that the earlier that you can test your code, the easier it is to fix the problem when problems occur. And that's because earlier in the pipeline, when you're in development and in CI and earlier in the software development lifecycle, you have more environments. So you have an environment per developer typically, and the developer is closer in time to when they've made the change that broke something. I'm sure you're familiar with this idea of like when something's fresh in your mind, it's easy to remember what you did and how it interacts with other parts of the system. Whereas if it's like 3 weeks later, and it's some big integration test that got set up and spun up, and at that point the problem is detected, versus being detected like within 30 seconds of you writing a code change, then it's much harder to find the person who needs to fix the problem, and for that person to remember that they even made the change.
Right. Yeah. Right. Now you're moving into much. Now it's not declarative at all. Now it's just mostly just you're following up with people, but now it becomes a team collaboration problem more than anything.
Yeah. Absolutely. And speaking of team collaboration problems, so the third issue that we're tackling is that one does not simply capture the state of 4 microservices at once. And what I'm talking about here is this idea of polyglot persistence. So when you have multiple microservices, what best practices says for microservices is that you should have a separate database for each microservice that needs to deal with state. So if you have an e-commerce application, then you'll have a database for your users service, and that might be a Postgres database, for example, and then you'll have another database for your orders service, and that might be using Mongo, and then you might have another database for your search for your site, and that would probably be using Elasticsearch or something that's appropriate for searching. And so you have this problem of polyglot persistence. It's not really a problem actually, but it does cause this. It's more just a fact about microservices that you end up with polyglot persistence. But the problem that it causes is that it becomes difficult to capture all of the state of all of those different microservices at once. And it makes it so awkward. It's not impossible, but it's fiddly and difficult to capture the state of all of those services that you see that teams just don't do it. So what that means
isn't this both the glory and the tragedy of Kubernetes? I mean, because it's
yeah.
it's such a connected infrastructure, right? And it opens up so many possibilities, but also creates so many possibilities, and that's the good and so it's the good and the bad thing about all those possibilities, right? I mean, you have these, you just have this interconnection that is just like, it's like a hive, right?
Yeah, absolutely. And I mean, the more microservices you have, the more different databases you have moving around. When you're interactively developing an application and you manage to get it into a weird state, then the only way that you can get someone to come and another developer to come and help you, like, understand that state and fix that state, is by asking them to come over to your desk and look at your computer, or by asking them to log into your machine, or by having some shared staging environment. The problem with that is that it means that you have to deal with that weird state, that interesting, that state that is poorly understood at that point in the development lifecycle. You have to deal with it immediately. You can't, like, put it on a shelf and then come back to it later. And so I'm sort of getting ahead of myself, but that's one of the things that we help with. So zooming out then, we're looking at problems at all different stages of the software development lifecycle. In production, we have these production outages that happen because tests aren't realistic enough. In CI, we have these slow and flaky end-to-end tests that manipulate real databases, that slow you down. They're flaky, so they make CI slow, and that reduces velocity. And in development, it's so hard to capture and share development states with microservices that nobody does it. And so if you sort of try and zoom out and ask the question, well, what's the common theme between all of these problems? The common theme is that you weren't in control of data. And so if we take another step back and think about what is modern software about, modern software is about velocity through control. So it's about being able to go faster by having things in declarative config, in a place that you can have a handle on it, frankly. And so if you think about history here, 20 years ago, version control came in, and people started version controlling their code, and everyone was like, hooray, we can stop emailing the code around, and we can stop having, like, when you're dealing with like a Microsoft Word document or something, you end up with like version latest .doc and version latest 1, version latest 2 .doc.
Oh, totally.
That was what version control fixed for code, right?
Yeah.
And that's awesome. And CI has also helped us get code, what I say, sort of in the context of this picture, into the circle of control. And CI means that you can have automated tests that run continuously, that test different inputs to your system. And that can help you validate that your code is correct. So both version control and CI tools like Jenkins and GitLab and Travis all help you get code into the circle of control. Now, you mentioned immutable infrastructure earlier, and I think that's really interesting, because immutable infrastructure has also allowed us to get our cloud resources, our infrastructure, into the circle of control. So systems like Terraform for IaaS resources, or Ansible, and then more recently Docker and Kubernetes, are all about bringing infrastructure into the circle of control by getting rid of mutable state hanging around on servers, making everything immutable, making it declarative, and putting it on infrastructure, putting it on systems that are self-healing like Kubernetes.
Right.
But the problem, if you look at this picture, your app is made up out of code, infrastructure, and data. And data is still outside the circle of control in this diagram. So our mission with Dotmesh is to fix that and bring data into the circle of control.
So I have a quick question here. So you mentioned, we bring up this concept of immutable infrastructure, right? And it, Kubernetes was developed with that in mind, wasn't it?
Absolutely. Yes.
Absolutely. And so, but it wasn't designed from its beginning for state, was it?
No, I mean, so Kubernetes developed the ability to support stateful workloads.
It does,
Um, it does. I mean, it developed it,
but it
and
wasn't
it's
really
been good.
originally meant for that, was it? Or was it, or was it in its beginning? Because that to me has always been a point of like question I've had. Did they really want to think about state when they were building
Yeah,
it from its start, or were
I
they,
think it. I
or
mean,
was it
so
something
I've
they
heard.
had to consider because it was just such an integral part of an app of a modern application?
Yeah, so I have spoken to Tim Hockin at Google about this, and some of his colleagues as well. And I think that so my understanding of it was that the Kubernetes founders knew that they needed to deal with that they knew that they wanted to build a system that could do all three of the major types of workloads, and that's stateless applications, stateful databases, and also batch workloads. And so it was designed initially, the first use case and the thing that they tackled first was the stateless applications, and that's what's also known as the 12-factor app. And that's also where Docker really took off, and that's where Docker started as well. And so that's what Kubernetes supported to begin with.
Right.
But I think they always had a vision to support stateful workloads as well, and you can see that in persistent volumes and stateful sets and so on, and separately also batch workloads. I think they see the world of applications as being divided up into those three categories.
And we're seeing it now with CSI, for example, right?
Yes, absolutely. Yeah.
I have some other questions about this, but I'll let you go on because I wonder sometimes if there's needs for different types of orchestrators, but that's another question for another time. But
indeed. Well, I'll push on through the deck and we'll come back to that.
Okay.
Cool. So then, I mean, if you buy this argument that code and infrastructure have been brought into the circle of control, but data is left out in the cold and is still largely a collection of manual processes and scripts, and sometimes even emailing a DBA and saying, or phoning them and saying, please give me a dump of production from last Thursday, which it sounds like it is from the conversations that we've had with people, then you can see that there is a need to bring data into the circle of control. But then the obvious question is, how do you do that? And the way that we're proposing that you do that is with a mesh. And so the mesh looks a little bit like this. It has this tool called .hub in the center. And then around the edge, you've got different stages of the development lifecycle. So you've got one developer, another developer, developer two. So developer one might be using their MacBook in a coffee shop, like in a sort of trendy scenario. Developer two might be using a VM on a cloud provider. Then you've got a CI system, and you've got staging or potentially multiple staging environments. Having a single or a fixed number of staging environments is seen as an anti-pattern now. So you probably, if you're quite advanced, you might have a staging environment per branch of your code. So that could be multiple staging environments. And then, of course, you have your production system. And that's where actual transactions are happening, where real users are interacting with your system, whatever it is that you're developing. Now, once you have a mesh, which is this sort of this layer that we've laid underneath all of these environments. And to be clear, this is a data mesh, not a service mesh.
Right.
And I can talk about the distinction between those two things later. But once you have this sort of data mesh, like lying underneath your entire infrastructure with .hub at the center, then you can do some cool stuff. So the first thing you can do is you can do some developer collaboration. So you remember I said, like, one does not simply capture the state of 4 microservices at once?
Right.
Well, now you can. So you've got 4 microservices running on your laptop. You can type a single command, dm commit, and you can make a commit into a data dot of the state of 4 applications at once, or 4 microservices at once, sorry. And then you can push that state up to the .hub. And that's what I mean by putting it on the shelf. So you can put the state that was interesting or weird for some reason on the shelf, and then you can come back to it later, or you can share it with another colleague who can help you fix it. They might be in a different building or a different country or a different time zone. And then that other developer can pick it up later. They might even not talk to you in the process of picking it up. They might just be looking at a GitHub issue that has a link to a URL on the .hub that has that state in it. And
So
they
the
can pick
so
up.
the so the state would be put on the shelf, and in what kind of example? When might you put the state on a shelf?
Okay, so there's a good example in our documentation. If you look in the tutorials section, there's a tutorial called library and another tutorial called collaboration. And they have three examples in, and my favorite example from that tutorial is there's a security vulnerability in an application. And the security vulnerability can only be triggered. So it's an application that has three different stateful services. It has a Redis database, and it has a Postgres database. The Redis database is for images that are being drawn. The Postgres database is for users. And then it also has a file store. So just like regular file uploads, it could be like S3 or something, but in the example, it just uses a directory full of images. And the interesting thing about the security vulnerability in the application is that it's only triggerable when all three of those states are in a certain weird state. So it's not, you can't figure out the vulnerability necessarily just by looking at the code, but you can, if you get the application into a certain state in all three of those databases, then you can capture that state, and then it's that state that you put on the shelf that your colleague can pull down. So you might be a developer wanting to push this off to the security team, or you might be a user who's discovered this problem, wants to capture the state and then share it with the team to fix the security vulnerability.
These literally are then snapshots in time. Yes. So you can track back the issues and solve them.
Absolutely.
Very quickly. Very quickly.
Absolutely. And so there's an interesting concept here, which is a concept of mean time to clue. Now, when you're a software developer and you're sitting down in front of an issue, like imagine you're the developer who picks up the bug saying there's a security vulnerability in the application. You pick up the bug, and usually the bug report just has some description. Normally, the person who's filed the bug report doesn't actually know what's causing the problem, and normally you don't have access to the data that they had access to when they were filing it either, or the environment that they were developing in or testing in. And so the job, and this is the bread and butter of software development, the job of software developers is to look for clues. It's kind of like a whodunit. You're trying to figure out like what caused this system to get into this state.
Right.
And with Dotmesh, you can reduce the mean time to clue, the average time it takes to get your first clue, by already having the state that reproduces the issue right in front of you when you pick up the issue.
So how often is the state captured? Is it's not captured, it's captured in batches, I imagine, right?
So at the moment, it's captured on demand whenever a developer types dm commit,
okay,
and then dm push.
Okay.
And that's exactly the same as like how often is your source code captured. It's whenever you make a git commit,
right,
and then push that git source code to version control. But there are some other use cases that do involve capturing every interval period of time. So I'll talk about those as well.
Oh, I can. That makes sense. It's done through Git then. So, okay. And then
it's a Git-like interface,
right,
rather than
being done
by Git itself. So then the other scenario that we have here is being able to capture failed CI runs. So we spoke to one company where they have this integration test pipeline. They have maybe 60 developers working on a project in microservices teams, maybe 10 different teams. And continuously, as these teams are shipping new code, all of the code is getting integrated and tested in a big end-to-end test pipeline. Now, if that pipeline goes red, the entire company has to stop committing code. And this person who I was speaking to about this says this wastes a lot of money, because think about how much the developers are paid per hour and how they just have to go and sit around and twiddle their thumbs.
Yeah.
And the reason for that is that when the CI pipeline went red, they had to stop the world so that someone could log into the CI server, the CI runner, and go and poke around the state of the databases in those tests in order to figure out what the problem was so that they could go back and fix it. This is another example of where it would be much more useful to be able to say, we don't want to have to deal with that state right now. We want to take that state, snapshot it, like you say, put it on the shelf, and then another developer can come along later and pick it up in their own time. And that means you don't have to block the entire company. You don't have to stop everyone making progress.
Because now there's, now that person can see it, in Git, for example, right? They can see that there's an open issue.
Yes. Yeah, so there'll be an issue in GitHub that might refer to a specific version of the code and a specific version of the data. And that's the new thing.
Right.
Like, you used to be able to just point at a specific version of the code. You can think about it like turning a one-dimensional thing into a two-dimensional thing. You previously just had this one dimension of code, and then you're adding this new dimension of data. So now you can sort of capture things in both dimensions at once.
Right. Okay. That's fascinating.
So then the last use case is being able to capture realistic data from production. And this, I'll be very honest, this is not something we do yet today. We're just announcing the 0.1 of Dotmesh.
Right.
But this is where we're going. And the goal here would be to make it possible to maybe every hour or every night take snapshots of your production data, scrub them, of course, because you need to pull out any personally identifiable information. And then after scrubbing, pull those snapshots into the .hub. And then from there, they can be distributed for lots of interesting use cases, like seeding your staging environment with realistic data from production, or pulling that realistic data into your tests and running continuous tests, like performance tests or regression tests against them. Okay. So yeah, those are the use cases.
So going back to let's move over. Why don't you move let's can you stop sharing the screen for a sec?
Yeah.
There we go. Great. So going through kind of, talking through this a little bit. Okay. So you're essentially taking these concepts of version control that we've seen become quite popular with GitHub and providing a similar approach to state, to that data in the container, for example, right? Yeah. And what has been the challenge with doing this over the past several years that now makes it possible?
Well, so it's interesting to see how the industry has evolved around this, especially around the container space. And I know you and I have both been in it since the beginning, so we've seen the whole evolution of containers to this point. Now, I think that what's really interesting is if you look at where containers and data were back when we founded Cluster HQ, when we got started with Flocker, we had a huge amount of work to do just connecting containers to data at all, and so we spent a lot of time just getting making that work, and Flocker was the first project that actually did that, and it was obviously an interesting idea because, as we mentioned earlier, the Kubernetes then developed the same capabilities, and so there was a real acknowledgement that actually it's not all about 12-factor apps, because even the most trivial application, like if you think of WordPress, for example, is a stateful application. It has a database.
Believe me, I know.
Indeed. So really, I mean, 12-factor apps are wonderful, but every real application has data at its heart.
Right.
And it's been a sort of evolution of the tooling, like Kubernetes, and also an evolution of the way that people are thinking about the immutable infrastructure and the systems around it, and to get us to the point where I really think the industry is ready for this kind of solution now in 2018.
I'm hearing more conversations about kind of this idea that, data has been such a kind of like a third party in the equation almost, where it has not really become part of the whole kind of, it's holistically not part of, of the process. It's more of like it's a separate entity, and that's due to its, it's the sensitive nature of that data and of that information. Last thing you want to do is lose that, right? And so that seems to be kind of the aspect here that we're the kind of this issue that we're coming up against right now is like, how do you think about them bringing in how do you think about bringing in the data, right? How can you think about then that state in a different kind of a way, because you can't just the immutable infrastructure idea, maybe we can touch on that a little bit, is a fantastic concept, and it's a fantastic kind of a premise for application development. It's a fantastic premise for distributed, thinking about how distributed this world really is. But this question of state brings up all kinds of issues, I think, that you start to see surface with big storage vendors. Like, well, that's why we have these, that's why we developed these gigantic boxes, eons ago. And that's why we're trying to think about how all this kind of, how all these different, this data can be more persistent and can be more effectively used.
Absolutely. And I think what you're seeing today is you really are seeing silos at different stages of the software development lifecycle.
Right.
So you see a silo of data in production with maybe a DBA team, and obviously, quite rightly, tight controls around that data and where it can move. But you also see silos in an individual developer's laptop at the complete other end of the spectrum. It's a silo because you don't have nice tools for getting that data out and managing it, dealing with it in the same way that you can deal with code, with version control, and with Docker images for your immutable infrastructure.
Mm-hmm. Luke, perhaps we can just conclude. Maybe you could just kind of sum up then what Dotmesh is, and tell us about a little bit about what you're doing now and what you have going forward over the next few months.
Yeah, absolutely. So, would you like a short demo, by the way?
Sure. Yeah.
Cool.
Okay, demo gods. Okay, great. Yeah, let's do a quick demo.
We've done the necessary praying to the demo gods. Well, you have anyway. I've done it in my head. And this, by the way, is a demo that you can try yourself on our website. So if you go to dotmesh.com and then just scroll down to try on Catacoda, then there's this demo environment where you can spin up a test of Dotmesh yourself. And I'll just do the first half of the demo to give you a taste for it. So you can start the scenario. And what we have here is we have a Linux machine, and it's just running Ubuntu. It could just as well be Docker with Docker for Mac on your Mac, or it could be your own Linux VM or your own Linux desktop. And so I'll show you how easy it is to install Dotmesh to begin with. So you run a single command which downloads a binary, and then you run this dm cluster init command, and that goes and pulls down a Docker image that contains Dotmesh, and it starts up the Dotmesh server. And that's it. Now you're done. Now you've got Dotmesh installed, and you're ready to start taking advantage of Datadots. So I can do dm version, and I can see that I've got a certain version of Dotmesh installed. I've got 0.1.1. And now I can start using Dotmesh. So I can do dm list, and that shows me my Datadots. And I'll show you what Datadots are in a second. At the moment, I haven't got any of them. So I'll start out by cloning this demo app, and I'll show you the Docker Compose file. So hopefully you can see this clearly enough on the screen. We've got a regular Docker Compose file here with a web container that's stateless. It's like a 12-factor app. But then, of course, you've got your data. You've got a Redis container that's also connected to this web container. And so we've got these 3 lines here: volume driver DM, and then volumes with a volume name called Moby Counter that's mounted into the data directory inside that container. So I do Docker Compose up -d, and now I have a data dot because that data dot was referenced in the Docker Compose file. So if I do DM list, I can now see that I've got my data dot and that it's selected, and now I can start making changes to it. So the first thing I'm going to do, so a data dot is like a Git repo for your data. So the first thing I can do is I can make a commit of the empty state. And so that very quickly captured the empty state. And I can use DM log. If you're familiar with Git, this will look very familiar as well, because now I can do a log of my commits. Now, I'm also going to create a new branch. So branches are like different sort of forks of of the hierarchy within Dotmesh. And I can now do DM branch, and just like Git, it shows me that I've had my master branch with that empty state on it, but I now also have branch A. So I can now load up the app in my browser, and it's a very, very simple app. So what I can do is I'll do a little drawing in the app. I'll do a T, and then I'll do an N, and then you get bonus points, by the way, for those beautiful drawings in this app.
Wow, that's beautiful. Look at this. TNS. Wow.
Yeah. Okay, so I've now got TNS, the new stack, of course, here, and I can do DM commit -m, and I can capture the state in the Redis container that has the location of these icons on the screen, because that's what the app does. It just staves into Redis where the location is. You can see I can reload the page and it remembers them. So that's stored on the server. The new stack is awesome, is my commit message. And now I can do DM checkout master. And the interesting thing now is that the app has gone back to the blank state. It's now
there we are.
Like, I click to add logos again. And now I can do DM checkout, branch A, and bingo, TNS is back.
Man, that is so cool.
So you can just start to get an idea of the power of the new workflows that this enables. Like, if I'm developing this application, if it has a bug in it, if I have a problem with it and I need to share that problem state with a colleague, then I can take this commit, and I won't show you now, but you can register for this service that we have called the Dot Hub. And the Dot Hub, it looks and feels a lot like GitHub. That's intentional. You can go in here and you can look at different states. This is from a different run that I did before. So you sign up for the Dot Hub. It's free, up to 1 GB of storage, free forever. And then you can push your data dots up into the Dot Hub to collaborate with colleagues.
That's so neat.
Nice. And I'll just point out as well, we've got on our docs site, I mentioned this earlier, there's a tutorial that uses a more advanced example. So there's this using Dotmesh as a library tutorial that has this security vulnerability example that I mentioned. And the thing that's nice about this tutorial is that it shows one of the other really powerful features of Dotmesh, where we have this slightly advanced version of this application that actually has 3 different data stores. So we've got a clicks database, a users database now, and the uploads database. And so you can actually try out and see for yourself that there's this security vulnerability in the application that you can only reproduce and fix by having all 3 of those states in a certain position at one time. So I'll stop sharing my screen, but I encourage everyone to check out the tutorial on Try Dotmesh and on dotmesh.com, and try out the library and collaboration tutorials if they want to dig a little bit deeper.
Luke Marsden, thank you very much for taking the time today to, have a discussion about what you're developing at Dotmesh. I really am very fascinated by this idea of capturing data. This idea of a data mesh versus a service mesh, I think, is an interesting contrast there. The idea of like being able to compare different states, so like you might be able in kind of the different kind of workflows that opens up is of real interest, and just what this might provide as this project grows. You're in point 1 right now, and I imagine you'll be building out the community over the next few months and start just getting out more and more new updates. So we look forward to hearing more about it as you make progress. Congratulations on getting this started.
Awesome. Thank you very much, Alex, and thanks for taking the time.
All right. Talk to you soon, Luke. Thank you.
Yes, have a great day.
You too.
You.
Bye. Listen to more episodes of the THENEWSTACK Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.